CCS development tools support the streaming of serial data through the microchip PIC, MCU, ICSP interface. Serial data streaming through the programming interface reduces costs during product development, production, and after deployment in the field. In this video tutorial, we're going to use a CCS ICD-U64 programmer debugger to show how to debug and configure a product using the product's ICSP interface. The product we are demonstrating turns off power if the input voltage is either too high or too low. Then it turns it back on when the input voltage is within a safe operating range. First, we'll open the header file. Let's add a line to the code to output serial data through the programming interface. The ICD option configures the compiler to output serial data through the programming interface instead of a serial port. We're using the standard CCS compiler printf functions to output the voltage readings over the programming interface during the normal operation, giving us the ability to monitor voltage in real time without halting the MCU to read the contents of a register. Using the compiler IDE, we'll recompile the code using the IDE's Build All option. Next, we'll reprogram the MCU and begin running the code. When the target starts to run, the ICD option in the source code will cause the serial port monitor to open automatically and data will begin streaming through the programming interface. We now see outputs from the printf statements using this development setup. While debugging the code, we're using a power supply to vary the input voltage to the target and monitor its response on the host PC. We're using the CCS ICD-U64 programmer debugger as the communication link between the target and the host PC, and also to program the MCU. We can see how the lockout switch is responding to voltage changes in real time. The second part of the code is used to configure the voltage trip points. Printf is used multiple times in this code to output user prompts and the current trip point settings. We also use getC to allow configuration of the trip points. During development, our diagnostic code gives us the ability to monitor and change the voltage trip points without halting the MCU, which would be required if a hardware debugger is used. We can reconfigure the target to modify the over and under voltage trip points without loading a new software image. The target is designed to enter into configuration mode whenever its manual reset button is held down during the power on. First, we'll turn the power off, then turn it back on while holding down the manual reset button. Now we are in the config mode. To adjust the trip point, we can use the plus and minus keys on the keyboard, then lock in the new value with the enter key. During production, line personnel can use this capability to display and set calibration data from a PC terminal, enter serial numbers, and run special production tests. This is especially useful since all these operations can be performed using one software image, minimizing software maintenance effort and cost. After the product is deployed, field engineers can use the CCS load to access fault logs, monitor performance, and diagnose problems. Operating parameters can be updated without having to reload an entirely new software image. In this example, we're accessing a data log that reports when the input voltage was out of spec, causing PowerGuard to shut power off. Now we're going to modify our source code so that the serial port monitor will chart the input and output values when data streaming starts. After the code is recompiled, the MCU is reprogrammed with CCS load and execution started, just as we've seen before. We've modified our test setup to use a function generator to sweep the voltage input for the lockout switch. It generates a very slow sine wave that drives the target. We can clearly see how the lockout switch responds to voltage inputs in real time. Serial Port Monitor can also generate a CSV file that can be imported into Excel for analysis. While use of serial ports to input and output text isn't new, implementation of the serial port requires hardware resources that may not be needed during normal operation. A full duplex serial port normally consumes 2 MCU pins for the UART, plus an RS-232 level translator and connector on the target board. Production boards may eliminate the component costs by not populating the translator and connector. However, the bare footprints still consume valuable real estate. This can negatively affect not only PCB costs, but also the end product. Use of the ICSP port for serial data streaming is a much more cost-effective option. Support for serial data streaming through the ICSP programming port is free for CCS compiler owners with software download rights and an ICD-U64 programmer debugger. Updated versions of the CCS compiler, CCS load, and ICD-U64 firmware are now available online to users wishing to take advantage of this powerful new capability. Just follow the URL shown on your screen to download your example code and updates.